Hello. Okay, I guess today we are gonna work on uh, writing the integration test in last three streams. I guess not really sure how many streams, but yes, in the last three streams we have written simple account, which is ERC4337 compliant. Compliant account contract, and then we have written unit test that covers almost 100% of the account contract. We still have all the other things, but yeah, we can see this works 100%. This covers 100%. So now we are gonna write one more test, which will be a big test that where we create a user operation, send it to entry point, and the entry point contract will validate and execute it. And we are gonna write two tests where entry point, where the thing fails, the user operation, and where the user operation is successfully validated and executed. So let's start by creating the file. Simple account integration.t.sol. Then you can pragma derivative 0.8.24. You can use whatever you want. I'm just gonna keep that consistent throughout. Now contract simple account integration is test. Now we are gonna import test. Import test from forge std/test.sol. Then first function is setup external, and we can put whatever. Now let's write another function, which is test user operation is successfully executed via entry point. External. Okay, let's create few things. We need water. What do we need? We need owner, entry point, simple account. What else? We also need receiver. Yeah, I guess that's it. We first need to import all those things. So import entry point from source/core/entry point.sol. Then import simple account from source/sample/ simple account dot soul, and the rest are just addresses, so we don't really need to care about them. We don't really need to import them. We are gonna care about them, but yeah. Account private. Instead of address, we are gonna create an account, which is just like standard function cheat code from Foundry, which creates address and a private key, which we need for ECDS signature. Next, what is owner? Then account private receiver. Now entry point private entry point simple account simple count. Okay, these things are done. Let's set them here. Owner equal to next account next receiver equal to account slash not slash the thing, whatever it is. Okay, next is creating the entry point. Entry point equal to new entry point and now finally simple account equal to new simple account, which will take entry point and owner dot address addr. Okay, now that is done. Let's first will construct the call data. So call data is bytes memory call data. Call data. Okay, let's call it something else. Underscore call data, which will be api.encode with selector, and we are going to get the selector from this execute dot selector. Next will be what destination, which is receiver address, receiver dot address comma 1 ether comma blank string, which is the call data, which will send to execute. For this case it's empty, we don't really need to think about it right now because we are just sending ether. Next is okay, fact user operation memory user op equal to fact user operation. Okay, this will be new. We need to import this. Fact user operation Let's copy this. Okay, sorry, this is in the interfaces, not in the core. Now we need to write all these things. Sender, which will be address of simple account. Next is nonce, which will be 0. Then call data, which will be no. Let me check. Init code will learn about it, but this will be empty bytes. Then call data equal to underscore call data. Now what's next? Account gas limit, pre-verification and gas fees. Okay, so let me open the EIP first. We haven't seen what the gas fees are. Let me go to user of no. Okay, so we have two fields, right? We have 3 fields of gas. So this account gas limit, then pre-verification gas, and then gas fees. But when you see in the user operation, we only see pre-verification gas limit. We don't see pre-verification gas limit. We don't see these two and these two. So it is explained here in the entry point definition. Instead of taking unpacked user operation, so like just user operation, it takes packed version of user operation where we are combining multiple fields. So init code will be combination of factory, address, and factory data. Here it says like address data. Then account gas limits will be verification gas and concatenation of verification gas and call gas. So you can see first bytes will be verification and first 16 bytes. So this is of type bytes 32, right? So the first 16 bytes of this value will be verification gas, and then second 16 will be call gas. Similarly, in the gas fee, max priority fees will be 16 bytes, first 16 bytes, and this will be second 16 bytes. So now that's out of the way, we need to create it. We need to create all those things. Let me see. Account gas limits. Let me check how to exactly do that on my blogs, which are on Medium and linked in the description. I do remember it, but I just let cross check. Okay, yeah, we can say bytes 32 and it uint 128. Can we do this? And uint 128. No, I don't think so. It's gonna combine it. Instead, let's do even 256. We can put like 100,000. We're just putting random numbers. In the real world, we have endpoints for estimating that. So we don't have to put random gas fees here. Also, we'll learn afterwards, like the gas fees. If you put excess gas fees, then I think no, then it will penalize you for that excess gas limit, like 10%. So it's not good idea to put a random number, but right now we are just gonna put, as this is a test, we can put random number here, which is 100,000. So and then we are going to move it 128 bytes, which is 128 bits, which is 16 bytes to the left, I think. Yes. And then we're gonna put like event 256, again 100,000. Next is pre-verification gas. Here you can just put same 100,000. Next is gas fees. Here we are telling how many gas, how much fees, I think. What was that? Yeah, maximum fee per gas, it tells, and maximum priority fee per gas. So it doesn't need to be 100,000. It can be like 50, something like that, or even 100. So it is basically this amount, I think. Yeah, base fee is 34 GUI and priority fees are 0.1 GUI. So we are telling this amount basically. Yeah, we are going to tell same thing. We are going to use similar method, just change the value, which is 50. We can even put 0 because in the test it can be 0. It will be 0 for the tests. We have to manually set it using Foundry cheat code to change the gas. How much gas is how much is the gas fee? We need to manually change it. Otherwise it's 0 pay. Okay, so next is paymaster data, which will be empty, and signature, which will be empty, because we need to sign it and then add the signature. So paymaster and data, it will be empty, and signature, which will also be empty. Okay, now what's issue? Identifier is not in the contract. Am I missing something? Memory, okay, not new. Yeah, sorry. Next, what we can do? yeah, we need to get user operation hash, then sign it and add a signature to user of, create bundle of user of, you can say array of user operations, user ops, send it to entry point, assert, like check our assumptions, let's say assumptions. Did we do that previously? Here somewhere. Simple account is, no, we didn't. We're also gonna test check if it emits. Okay, we'll write that afterwards, like the event check if correct events are emitted. What is that? Okay, let's get the user operation hash. Bytes 32 user op hash equal to user operation hash equal to entry point dot get user operation hash user op hash, then pass the user operation. This should do it. The next is we need to import ECDSA and message hash utils. This, no, not ECDSA, we already have the cheat code, so we don't really need it. Okay, so we already know it. On the user op hash equal to each send message user op hash. Next thing is to create it. Okay, so let's take a look at entry point again. So entry point definition, it tells you what entry point accepts. We also should have a use entry point functionalities. So you can see handle ops. There will be a function called handle ops in the entry point contract, which is where the bundlers will send all the what you can call them user operations basically. So, and that function will accept user operation array. We'll check the definition here. Handle ops, yes. So you can see takes user operation, where is this? Yeah, it takes user operation array and the address of the bundler. So where bundler is basically a entity who sends the user operations on chain, and they get refunded via a mechanism that we'll learn afterwards. But this is not basically free, like the sending of user operations. It still costs you ETH, just not uh, when sending the user operation. Instead, it sends like someone else sends the user operation on chain, and then you pay for that afterwards, and you pay to that entity instead of you paying yourself. So we need to create array of user operations, which is basically impact user operations array memory, then user ops equal to fact user operation array 1. Okay, no, I think I'm yeah, right, now that's correct. And we can add it using user ops dot z will access first element and then assign it the user op. Okay, and that is done. We can check. Oh, sorry. We also need to create a bundler. Okay, we also have the bundler. Let's deal some ETH to them, all the parties. Deal bundler address equal to 10 ether. Next is owner address. No, not owner. Owner doesn't need ETH, but the simple account does. Simple account also needs ETH, so we're gonna deal some ETH with that address. Simple account. No, this will be simple account with small s. Okay. And next will be we're going to vm.prank bundler dot address and then entry point dot handle ops handle ops user operations user ops comma payable because it shows in the function signature that we need a payable address. So payable payable bundler dot address. Okay, our assumption, no, we didn't sign it and added that vm.sign. This will return event 8 v bytes 32 r and bytes 32 s. So vm.sign formatted user operation, and then first the owner dot e and then formatted user operation. Next we'll assign it to user op signature equal to avi.encode pact r s and v. Okay, that's done. Our first assumption is assert equal to, you can also use like vm.assert equal to receiver address dot balance equal to 1 ether. Okay, I think our test is done. Like, we have written the test, so let's try to run it using dash like match test flag forge dash empty. Okay, test dash empty this and see, and it passes. So most of the things that we assumed here, like we done, are true, and we can use it. We can also remove some things like formatting this. I don't know why. Like, it converts it to personal signature. Okay, maybe let's see. Like, yeah, it's standard practice. We can add it. Not standard practice. We are just following the specification, or like ER standard. Yeah, we are following a standard, so I can call it a standard practice. Okay, next assumption is, let's first look at the trace and we'll see. So if you see here, first it runs the setup function and then it executes. Okay, yeah, then it executes this handle user op, and you can see handle user op goes down till the very end here before assert. In that we have multiple events, so we're going to check how many events the execution of user op executes. So all the emit, so you can see here this is an event, but this is in the setup, so we can ignore that. We need events emitted after handle. We call handle user op. So there is no event here, no event here, there is no event here. There is one event called deposit. So what is a deposit? The deposit is basically, I guess, let me see. This is the new owner. What was this? Okay, let me check which. This is an unknown. But where is this happening? Okay, what we are dealing it to. First deal is to bundler, second is to, okay, this is our simple account. So deposits are basically the thing where if you pay more gas fees, more in total gas, so you can calculate total gas by multiplying these things, these values with this. So 50 plus 100,000, like it should be 500,000. I'll come back to you with the actual calculations, but right now we can assume that this is basically the 6 million, I guess. How much is this? 60 million WEI is deposited into something called deposit. You can see it here also. Stake manager, balance of. Okay, so deposit is basically, instead of taking it from your simple account balance, here how we dealt like this, right? Instead of doing that, we can increase the deposit by calling like entry point deposit 2, then give it address of simple account and send a value of 1 ether. Okay, before doing that, okay, let's see what is the balance at the end of simple account simple account. Address equal to address simple account dot balance. Okay, we need to import console. Console 2 and again execute it. So you can see here the last log was our console log of balance, but we only sent 1 ether. Why this is like, we have balance, we have given balance of 10, we sent 1 ether to receiver, then why this balance is not 9, instead it's like 8.9999 something? Is because the gas fees are deducted from our account. But if we have seen this deposit function, right? So deposit is the concept where if you have high enough deposit, it will take gas fees from the deposit instead of your account every time, because it costs us 32,000 gas. How much gas ether transfer takes? Question mark. 21,000. It takes 21,000. Let me check. I was reading something today. But just a second. Okay, I was reading this. Yeah, it doesn't actually specify something. 2100 or 21,000. What is this? Okay, okay, it's somewhere it says like 21,000, and here it's saying something else. Okay, I know it costs. Okay, we can go to our trusty resource. Saffron. Okay, so with this, we know it costs this much. So every time we don't need to send the gas. Instead, we can just like we with deposits we save that amount of gas from deducting every time. So anyone can just like increase the deposit and not pay the gas fees. Sorry, increase the deposit and not pay the gas fees from their account to save the gas, which is deposit to, and we can pass address. We have seen this function, deposit to, no. Okay, so deposit to text an address, and it's a payable function, so we can send any amount with it. Actually, this is the address we need. This is the address for which we need to increase the deposit. Then value will be 1 ether, let's say. And now if we execute this, oh no, we still need to use this because we need to send 1 ether. To send that 1 ether, we need 1 ether. But now we'll see this will be now 9 instead of 8 point something. You see? And there is no deposit function here. Deposit, what we can say, event. So you saw like what is the deposit and how it's used. It deducts the gas fees from your account instead of deducts the gas fees from your deposit instead of taking it out of your account balance, as you are the one paying it in any case, but the saving of gas will happen. Now ignore this, but let's check if this event is emitted, user operation event, where it tells us what was the user operation hash. We already have that here. Then sender address, we know simple account address. Then paymaster, it will be 0 address because we didn't use paymaster. Then nonce, then it'll check like if this was successful. If the user operation is successfully executed, this value should be true. And as we saw, like everything was executed, so the success value is actually true. Now how to do that? In the Foundry book, we have something called record log. Yes, so you can see here vm.record log, and then this checks everything. and then we can get all the recorded logs from the stored array using get recorded logs function. So you can see here how this is taking the entries, and then we can see like assert entry length. What is entry length? Then we can take the topics. Topics is basically this, and then the rest of the things. We can also get individual values. So let's see how to do that. Okay. So before this, let's put vm.record logs. Now at the end, we can first assert. Now we first need to get all the logs. So vm.logs array memory logs equal to vm.get recorded logs. So we are just using same thing from the documentation as we saw here. vm capital log and the rest of the things. So this was capital log. Okay, not found. So we also need to import this from Forge standard library similar to test, which is vm. Okay, the error is resolved. Well, okay, entry length we know it should be 3, and then rest of the things we can figure it out like by decoding the values. So let's assert vm.assert equal to logs dot length 3. Let's okay, no, let's execute this, and if our assumption is true, it should pass. Yes, so there are 3 entries. Out of those 3 entries, we need the third entry. So the index will be 2. Now we can decode those with what we need is nonce. Okay, we can also add here. Ignore this. All the entries that are in here, we can decode those using avr.decode. So un256 nonce equal to and success equal to avr.decode logs index 2 data, and then we'll pass the tuple which is un256 and boolean. And then we'll assert that Okay. Success true, and none should be 0. We don't have to run every time, tests every time, but I'm just trying to show, so I'm running it. So you can see the test passed. So the event we got has nonce of 2, and this value is 2. So what else was there? There was paymaster, user operation hash. Let's see here. This is the structure of the event. So byte 32, address, event 256, and boolean. Let's get all those things. Event 256, event 256, and now this will be byte 32 actual hash event 256, sorry, address sender, then address paymaster. Okay, it should be address. Okay, then vm.assert actual hash is equal to user operation hash. What's the issue here? Okay, did I mess up somewhere? Oh, double S, sorry. Then we have sender, which should be equal to address of simple account, and lastly paymaster should be address 0. Okay, where did we mess up? Let's see. We are running into issue here. What's the issue? I don't know. I don't want to debug that right now. There is a better way to test this. We know this test case passes. Let's go for the better option, which I wanted to show anyway. vm.expect emit, which is basically which tells the test that we are expecting an event, and for the event we are going to expect emit, and we are going to tell how many index parameters are there and do we know them. No, how many index parameters are there, and yes, do we know them, and if the non-index parameters are there and do we know them. So there can be only 3 indexed parameters which are, and we know all of them. Pay user operation hash, we have it. Sender address, which is simple account address, we have that, and paymaster, which will be 0, basically 0 address, we also know that. So we're gonna put true true, true, false, and then the address from which the event will emit, which is entry point. Then we are actually going to emit it, which is our entry point dot user. Okay, let's first actually import it. Where should it? Yes, we should do it here. I entry point. Okay, now that is done, we can use user operation event, then pass the correct values. Which is second will be simple account, third will be address 0. Rest of the parameters, these 4 things, we don't know them, but we still have to give some values here, otherwise the event see, like, it gives you something else, some error. It expected 7 and got 3, so you can just put 0, false, 0 and 0. We know that this is not correct because we are testing them here. So if this function call emits an operation, okay, if this function call emits an event, then this will be true and the test won't revert, or test won't fail basically. But if you change any of these values 1, 2, 3, the test will definitely fail. So let's see first the failure case. We know the sender won't be address 0. What happens when we call this? It fails. It says, let's see, like in the some debug, it tells you log is not equal to expected log. But if we change it to simple account and execute it, it tells you log y 4 is not equal to 3. Okay, so one more thing here we are emitting an event which is also recorded in this record logs, but if we move it down, now it should pass. Okay, so pass. It doesn't actually matter what happens, but you understood, right? If there is an event emitted, it will record it. Anything after this, any event after this, like, it will record it and put it in the record logs. So I think we have tested the whole thing. We haven't tested for the failure case where validation fails, but we can assume we'll test it tomorrow, or we can just assume like this whole thing, like the unit test, we have already checked. We get an error, not error but correct return value, which is sig validation failed for wrong signature. We just need to here, like in this test, we just need to change this vm.sign, and then we need to put something else and then see what happens, and hopefully it should fail. Okay, that's it for the today's stream. Tomorrow we are gonna start testing entry point, because we have minimum knowledge to start like understanding what is happening in the entry point and how things go. So we're gonna deep dive into entry point contract tomorrow and go over line by line, at least for the simple account thing, say, like simple account scenario, but not like the paymaster one. For the paymaster, we are gonna learn what are the paymasters first, and then we are going to go and write the entry point tests for paymaster.